Good afternoon, everyone, and welcome to the fourth training webinar from the SYMBIOSYST Horizon project. Today afternoon, we will focus on parameters and tools for monitoring agrivoltaic systems. Thank you, everybody, to join us and to keep on exploring this new and fascinating and innovative topic, which is agrivoltaic systems. I will share with you just a few slides for the introduction. Agrivoltaic system interact with the soil, plant, and atmosphere continuum, so-called SPAC. This is why we have to monitor the way agri-PV systems interact in this continuum relationship. In the SYMBIOSYST project, we are testing through monitoring different hypotheses and types of agrivoltaic systems demonstrator. Each one has its own unique feature, strengths, limitation. We have applications in Italy, in Spain, and the Netherlands. And through this, we aim to contribute to the broader community understanding of agrivoltaic systems. And to do this, of course, we need to monitor. The topic monitoring agrivoltaic systems is increasing in research. So we have a higher interest about this. If you quickly scan on research papers, scientific papers on Google Scholar by digiting agrivoltaics and monitoring, you will see how much the number of publications increased in the last years, reaching in 2024 more than 360 publications focusing on this topic. The development of key performance indicators, of course, can provide a robust framework for evaluating the sustainability and effectiveness of agrivoltaic systems. The key performance indicators can support, of course, demonstrators in agrivoltaics demonstrator project in how much they can contribute to social, environmental, and economic issues related to the agrivoltaics. In the SYMBIOSYST project, we highlighted early in the deliverable 5.2, and we different categories of indicators related to agrivoltaics. As you can see, there is a huge amount of indicators that can be used for categories like end-of-life agriculture, water, land use, biodiversity, microclimate, plant phenology, post-harvest quality traits, soil improvement and preservation, and a global greenhouse gas emission saving in agriculture machinery activities. As you can see, especially with regards to plant phenology and microclimate and the quality of crops, there is so much to monitor about. SYMBIOSYST already published a deliverable called Design of Demonstrators Testing Program that you can find a lot of information with regards to parameters to monitor the performance of agrivoltaic systems. You can there find information of what parameters will be evaluated in the SYMBIOSYST demonstrator project and the first outcomes that we pursue. So this is what we are doing in the research, and the focus of this webinar is what's going on with monitoring agrivoltaic systems in industry. So for this reason, we invited two speakers. The first speaker is Foglia from I-Pergola, and the second speaker is Nolan Picard in Weenat, to see what's going on in industry, because Of course, there is evidence of the necessity in research to develop all the monitoring systems in agrivoltaic systems. On the other side, we want to see what the industry can offer to even industry and other that are interested in developing their agrivoltaic system. Thank you very much. So now, please, Ivan, you can start with your presentation. Thank you. I'm sorry, of course, before I even start, I want to remember that please, we are going to dedicate the final part of the webinar to questions and answers. So you can start writing down your questions if you have in the opposite section of questions and answers. Please do not use the normal chats, but we'll be collecting the questions along the webinar in the question and answer section. Thank you.
Can you see my screen?
Yeah. Can you put it in full screen, please, Ivan? Yes. Yeah,
okay, welcome everybody.
Yeah.
Thank you, Paolo, for the invitation. I'm Ivan Foglia from I-Pergola, and I would like to describe our idea of monitoring energy and environmental in agrivoltaic systems. So first of all, who we are. We are a young startup based in Brescia. We are also a benefit company. The I of I-Pergola stay for intelligence. And we put a lot of thought and lots of focus on this word. Currently, we are 17 people, and we are born 2 years ago in 2022. And by the end of this year, we will install 15 megawatts of power, both agrivoltaic and ground PV mounted system. We started in Brescia, as I told you, but we have several projects also in the center part of Italy and in south, especially in Puglia. We are focused mainly on 4 kinds of photovoltaic devices: ground PV, agri-photovoltaic, floating, and industrial rooftops. We are also member of IAS, the Italian Association for Sustainable Agrivoltaic, and it's very important for us. We joined this association last year. We are also member of Confindustria Brescia and SunPower, that is famous all in the world as one of the biggest PV manufacturers. Why it's very important, the monitoring of crop and energy production. As Paolo told you before, we have now this idea in Italy when starting to spreading the agrivoltaic installations, but there are some issues. One of them, it's connected with the lackness of information. We don't have a lot of data, and we should test what happened to the crops below the solar panels. What are the best and the worst scenario that can happen after below that. Second, we should not simply find how to monitoring the crops and energy production, but we should find the best way to monitor these systems to ensure efficiency and feasibility. The new challenge, obviously, it's how to fit the agrivoltaic systems with higher solar panel performance and crop health. This is our first plant in North Italy, near Verona. As you can see, we have an anemometer and other tools to check the condition of temperature, moisture, and wind speed, for example. We are focused mainly at the beginning, of course, in how to integrate the track the solar the energy production, because of course there's a bigger know-how on this production. So we started to think about what we can do with a tracker, a system that can follow the sun from the morning until the evening. And we can currently maximize the energy production using solar tracking, as you can see in the first picture. We can also make the panels turn up to 90 degrees, for example, to let the biggest amount of sunlight reach the plants. There's also snow unleading for safety and during winter, for example. There's innovative systems that allow you to protect your panels during treatment to avoid soiling. And there's also software that talk with a PLC to allow you to avoid dangerous situation when wind is stronger. For what concern this part, that's the SCADA system that we deal within, and we have different software and hardware integrated, but we'll also continue our study because we have to improve it, of course. We have probes for studying the soil and a metro console to check the meteorological and environmental data. We collect them using InfluxDB. Is an app that allow you to have to construct and to manage a database, and Grafana to check and comparative and make comparative analysis of the graphic that you obtain. And we also started to use digital twin to it's a way to create a digital plant and check what happened, and also make how can I say predictive analysis. And as I told you, everything is connected to a PLC. We are using Siemens in this moment, but we can customize every solution, of course. So at the end, what happened in the environment and in the soil passed through this diagram. We can check and see what happened, and our aim is to maximize, or better, to optimize, in this case, the energy production. So at the end, the PLC will control 4 engines, and each one of them, it's connected to the tracker system, so we can check and operate very fastly, very quick. For what concerns the agri-system, it's a work in progress. because we are starting also to deal and make partnership with university and other scientific research center, and because most of us are electrical or energy engineers, so we should also to cooperate with agricultural researcher and agronomic institute. We are starting to use multispectral cameras and software with AI. We are more focused on shadow ratio, temperature. PAR is the photovoltaic active radiation, and the ATC, the evapotranspiration coefficient on plants. And our aim is to give an input that talk with the same diagram, the same SCADA diagram that I showed before. So in the end, we will not simply maximize the energy production, as I told you, but optimize energy production and also crop health. This is one of our first APV systems. It is in Bari, in Puglia. It's a partnership with CEAM. It's the Center of Agricultural Studies in the Mediterranean area. It's 1L, it means one landscape, the way we put the solar panels on the tracker. Poles are in concrete, reinforced concrete, and models are SunPower bifacial. Below them, you can see lemon trees. It's a small plants, more or less 20 kilowatts. I'm not sure about the right power, but in this case, we were not focused in produce the biggest amount of energy, but I repeat you, it's just an experimental system. And the second one, it's with the Università of Sacro Cuore Cattolica in the north. So currently we are studying what happened in the south Italy and also in the north, in Milan. It's always 1L, one landscape, as you can see, always bifacial models, SunPower also in this case. But we are using steel pole, not concrete. If you are wondering what is these things, it's a ballast to reduce the torque during the rotation of model. So it allows us to reduce the energy used for the engine during the rotation of the system itself. In this case, below the models, we have vineyard. So what comes next? This is another plant in Puglia. It's 100 kilowatt with Mandarino Tango below the models. It's always single landscape, as you can see, with pole in reinforced concrete. And we should, of course, continue the innovation and monitoring what happened in a farm. We don't work and have partnerships simply with university and research center, but also with farmers too. So we have specific partnership to know and to spread the information and the yield that the farmers will have on this land. We have to scale the solution. The plants that I showed you are 20, 25, 100 kilowatts. We have to imagine what happened in a 1 megawatt or 2 or 10 megawatts APV systems. And we are also we have a duty. We are working also with AIAS, because it's very important to join and to spread the information with other organizations and with the stakeholders. And yes, the next step for 2025 for I-Pergola, it's very ambitious. We have 40 megawatts, so we are slowly come out to the startup dimension. And we have 40 megawatts of order intake based on PV and APV, both systems. Thank you for the attention.
Thank you, Ivan, for your presentation. I think really relevant, but discussions and questions at the end. Thank you. So now I invite Nolan Picard from the Weenat to share the screen and give us your presentation. Thank you, Nolan.
Yeah, sure. Do you see my screen?
Yeah.
Okay, perfect. Well, hello everyone. I'm Nolan Picard. I'm French, as you may hear in the accent. I work in Weenat company, which is a French-based company. I'm in charge of international relations, and I'm going to present you about Weenat and what we can do in Agrivoltaic project. Weenat is a monitoring company. Basically, Weenat is a sensor, an IoT company. We've been working for 10 years now in monitoring data for farmers and the farming industry. And for a couple of years now, we've been partners in the development of the agrivoltaic projects, mainly in France. We are a member of kind of an equivalent of AES, which is France Agrivoltaïsme. And we are one of the referent of the sensor partners for the development on the investigation side or on the production side. So I'm going to explain you a bit where we come from and get to the point afterwards about what we can give in a project, what is our value, and how we can contribute to the development of that question of the monitoring for agrivoltaic project. I excuse the mix of language in the presentation because you may find a bit of Italian and English, but afterwards I will share complete English or Italian or both presentation to Symbiosis so they can share with the audience. Just as a reminder for those, so what I just explained, so Weenat is from the 2014, and we first were created for the purpose of creating a rain gauge, automatic rain gauge for farmers in the north of France. So that was the start of the company, and we quickly began to develop all kind of sensors for all the soil and climatic parameters that influence the growth of the crops. So then we began to make soil probes. Then the company also acquired another company was called Weather Measures, which is specialized in specialized data for large-scale project. So basically, algorithm-based data for weather data on scale like a region, a country, on which we cannot install sensor every square kilometer. We already have an approximation on all the atmospheric parameter based on that algorithm from Weather Measures. And who we are now. So now we're a company about 60 persons. We worked in whole Europe, but basically we work in Central and Western Europe. Our main base is in France, and the two other countries in which we have more activity are Germany and Spain. And now we work on all different crops because we work from Sicily to Finland. So we have all the range of different possibilities in our users. Basically, we give three three parts in the project we're working on. We manufacture in Nantes, France, sensor for just measuring. We have our own platform, but we're also compatible with other platform to give the data for the user, technician, or farmers to develop solution. And we also have a layer of analysis and recommendation for when people are interested on that matter. We work for the farming production from the start. So I'm doing the transition to agrivoltaic just after. But in fact, we develop sensors in response to problems on the field. So the first question was, I want to know what is the weather like on that specific point, because I'm not there, or I want to make a register of the data. Then we move to crop protection, because we come from the north with a lot of disease pressure. And then we began to work on two other aspects important for us, which is control of irrigation and frost risk management. And all our system is made on the same basis, which is independent sensor, completely autonomous, to be installed anywhere. Which is one of the reasons why we also work in agrivoltaic, because sometimes there's like an installation, a really remote installation. We can install the sensor anywhere without the need of further cables or communication. So any module has the same communication. We work with different kind of communication system, LoRaWAN, Sigfox, NB-OT, LTE-M, to adapt to what coverage is the best in any situation. So from this system, which I'm going to just show you three different sensors, which are the main parameters we mainly monitor in farming and agrivoltaic system. We can place different point of measurement on specific point. On this example is what we call a basic weather station with rainfall, humidity, and temperature, but it's the same base for a soil sensor. There's a variety of way of measuring water availability in the soil. One is a tensiometer measuring the pressure, so we can do that. So this is an example in uva di tavola in grapes about what the farmer can monitor. But we can also do other system with capacitive sensor, which allows us to determine soil capacity campo, to have this information as well, which is a limitation on the tensiometer style. And we can do that with every parameter. So I'm gonna quickly pass on that point to go to other parameter of interest, specifically in the agrivoltaics project, on which we're going to have a direct influence on the solar radiation, which is finally getting to the plants and the soil. So for this purpose, we have autonomous on mobile, either pyranometer for the global radiation, either PAR sensor for the radiation, the part of the radiation used for photosynthesis. So every system is independent to be placed on different point of investigation, because and we have that for 2 years now, because of the integration on the France Agrivoltaic. There's a lot of different investigation going on, placing the sensor in specific points, and the need of one data and one specific point, and maybe not at the same point that where we measure wind or temperature. I want that data there. So that's what we come across on the problematics, and that's why we have this autonomous sensor. The problematics we are with all that material we're working with are diverse, and they're not the same 2 years ago when the first project maybe were entering in production on our first zone of interest, which was France at the time. That the problem we are experiencing now. So the first question were, what is the influence of the installation on the crops? Will I be still able to maintain the production, to produce? So the first was a question of worrying. So which environment we are creating, and is it still sustainable to have agriculture below the panels? So first question was investigation, measuring to ensure we still have compatible conditions. on test field on different region of France. And more recently, there's been a lot of articles, there's a lot of project going on around the world, and it has been explained in the introduction. We already show a lot, see a lot of clear positive effects of some kinds, and now the system is more to help in investigating some risk. Like we know we have some effect for sure on the risk of heavy rain, a high risk of hailstorms below the panel. We may have some protection, the effect on the strong winds barrier we can experience, and the last kind of the most important recently is the effect on the excess of temperature and solar radiation excess, and in the end the hydric stress. So how we can manage differently or better the irrigation pressure on our crops. And the last kind of development, that is something that in fact Ivan was explaining before with I-Pergola, is how we adapt our system also, not only fixed but also in mobile system. Depending on the data we're experiencing, we want to be able to move our panels to adapt to the crops, which is mean we have kind of two objectives here. We need to maximize the electricity production because this is one of the matter, and we also need to maximize the crop growth. So the end point is a bit to have movement algorithm of movement which are focused on the good compromise between the two things at all time. So this is kind of with our humble performance of monitoring, we participate in different projects. So this is two development project in which we participated with the monitoring in France for the left one, and in Germany for the right one, on which we set different data all over the field, depending on also the R&D team of the solar developer. On this case, I think it was I don't remember the name, but I think one is TSO in France, and maybe the other one is the German one. I don't remember, but the French one we worked with different one. One is TSO, one is Umbrea, and with that information, we help developing. On the first case was investigation, knowing what is the concrete effect on the panels, and also we have developing integrating our data in also learning process to develop algorithm. We do not do it at Weenat. We are the monitoring part of the system. So here, for example, is one installation of monitoring that we made for some total energy development field. So we have our own platform that helps on the monitoring, but you can also, it's also been done a lot, integrate the raw data of the sensor in more advanced development tool developed by the solar agri developer, solar themselves. So that's what I was explaining here. It's like we have at Weenat the two performance about the monitoring platform and the monitoring sensor, but because of our story, which is mainly focused on the farmer side, on the user aspect, we in general integrate our data in external platform, which are made from the point of view of the electricity producer also. So basically, this is what Weenat is doing on the agrivoltaic part, which is monitoring. And we have an experience of a diversity of different installation, and we collaborate and we are completely open to be integrated in different platforms, which is kind of our strength, being able to adapt in any system. So this is what I wanted to present you today, and I'm gonna stop here the sharing.
Thank you, Nolan, for your presentation. Thank you very much. So then we can maybe start the question and answer session. We got some questions in the opposite section. So if you agree, I will start with that. The first question is for Ivan. Yes. And since when are the agrivoltaic systems in Bari and Milan in operation? Do you already have any comments on the product quality, lemons and grapes?
Not yet. We started this year in Bari this spring, and in Milan, I suppose a couple of months ago, maybe less.
Okay.
So they are very new.
Yeah, you could see from the very young plants, of course. Thank you, Ivan. The second question is in Italian. I'll try to translate for you all from Francesco Brunelli. Do exist already study regarding the impact of agrivoltaic system on the soil quality? Are there any guidelines to do assessment of soil quality? Maybe I can answer also to this. Well, the effect on the soil quality, SYMBIOSYST 1 year ago organized a webinar on biodiversity below and above the ground in agrivoltaic systems, and we were currently discussing about the soil biological quality. And there are some installations that can already provide some data, also in Italy. And because those installations are now 10 years old, but if we can imagine, of course, the mechanisms in soil quality, in soil regeneration that can be safeguarded by agrivoltaic system require longer times. So because soil formation and soil quality are very slow processes. So maybe it can take 20, 30 years, 40, 50 years to recover a soil. So I'm afraid to say we don't have enough data yet to assess that. With regards to the guidelines, we don't really require guidelines because it's a standard soil quality assessment that every institution, every university, of course, can do with specific instruments. But in general, we can say that if the soil quality, so the biological quality of soil, can be enhanced by a better water content of the soil and stability of the soil, so practicing, for example, minimum tillage for crops. And that's something that you also discussed about in the last webinar last June here in SYMBIOSYST, that was the relationship in between agrivoltaic system and sustainable farming. Yes, we can say that, because of course agrivoltaics, by providing shading on the soil and so enhancing the nexus soil plant atmosphere, because it can reduce evapotranspiration, of course, can go in that direction. But we don't have so much representative data yet. But yes, we can do that, but we need time to assess, of course. I don't know if you want to integrate with more answers, if you know about the experiences, Nolan, Ivan, about this.
On the soil effect, it's a bit too early on the site to have feedback. Even if we don't always have the feedback from the developers themselves, because a lot of that is classified for development, because there's a lot of new solution coming out. So we have part of the information, but as far as I'm concerned, we don't have conclusive information about the really good or bad effect on the soil, let's say organic matter or soil texture so far. It's too early to tell.
Yes, thank you, Nolan. I do perfectly agree. maybe we can add also that, of course, that's on the choice, on the strategy of agrivoltaic system management, because if the farmer agrees, of course, can start more regenerative processes in the soil. So I know, for example, a specific case where the agrivoltaic system was combined with minimum tillage. So, and it was just with a standard crops rotation in crop arable land. So that's exactly. So the positive nexus, it depends, of course, on the farming strategy, and there's nothing that can make agrivoltaic systems afflicting this. On the contrary, can be promoting that, because even providing additional income to farmers can some way push farmers in being more sustainable in farming too. So we are quite late and we have a lot of questions. Elisa Gatto, for Nolan, in order to achieve comprehensive and representative monitoring of what density of measurement stations per hectare is anticipated to be necessary for the project. So what's the density of station per hectare, Nolan?
It's an interesting point, and it always is a good question regarding if it's agrivoltaic or just farming. It depends on which parameter we are looking at. For example, on the soil data, we usually advise 3 repetition per site on the measurement to have consistent data. But we do that because a lot of papers on an investigation do the same, which is our position. But in fact, you see now a lot of inside development which are made the different way. So this is on the soil. We advise repetition for 2 reasons. Because of the consistency of the data itself, and also because in the soil sensor you may have false bad contact in the time, and so you may require to reinstall some sensor, and by this time you want to have a still data, an historical all the time. So we will do repetition in case we have one technical problem with a sensor which need to be reinstalled. But this is just like to have good practice on the soil part. On the atmospheric part, well, we kind of have a different view now, but before we used to answer that question without the solar panels, which was okay if we check the zone on question of topography of the area, and we say, okay, if we have a density of every 3 kilometers, we have a measurement, we find if we have a flat topography. And every time we add a change in the geography topography, which is like a level or a river, we put an extra measurement there. Now with the solar panel installation, this is no more a question of surface in many cases, because it's a lot of test installation, which sometimes are 1 hectare, sometimes less, sometimes a bit more. So we cannot really keep to a measurement per surface, because it's a lot more to like a test field without and a test field with. So in general, we have a high density if you compare it to without panels, because you may have 1 or 2 measurement for like 1 hectare or even more, because the system is small because of the test operation. So we don't have still to answer the question about the large scale project, because we are mostly used for investigation and we just respect the repetition to have a concrete value. We don't answer the question about homogeneity. What was the question of Elisa? A density of, yeah, we usually have 1 or 2 points on the test and with the solar panel case in each case, and we have 3 repetition on the soil, which is our recommendation on the site. But what will happen when we'll have large scale installation needs to be answered yet.
Thank you, Nolan. Another question from Sabina Ellen Andrei for I-Pergola for Ivan. Are you considering any vertical projects with vertical panels?
No, we are working mainly with single axis tracker.
Yeah. Thank you. Next questions from Anna Ellis for all of you. Do any of you have an experience idea of and if the PV panels are affected by the organic material humidity below the panels compared to rooftop mounted panels?
Well, do you want to respond first, Nolan?
No, I was about to say I don't, Ivan, so please go for it.
If we use, for example, double glass solar panels, it's better if we compare it with a normal panel used in rooftop systems, because glass it's more resistant if you compare with a polymer used in rooftop systems. But also in this case, we don't have a strong data set, so I can simply report this information.
Yeah, maybe I can add. Maybe if Anna's question was more in general. I mean, I suppose, of course, the facial panels can benefit from vegetation below, because vegetation below with evapotranspiration and humidity will have a cooling effect on panels. So the panels, the bifacial will be cooled by
Well, I didn't
vegetation.
understand.
So of course there is a positive relationship. Bifacial panel can produce better than on rooftop if on vegetations. And it is true that there is quite evidence already, some research. Also, a colleague of us here in ETA-Florence, Lucia Montonio, is doing PhD on this. And also rooftops, the combination of roof gardens with photovoltaics instead of positioning panels on the concrete or other, but on vegetation will also create benefits on rooftop if rooftop are planted. Yes. Thank you. Next question. Ivo Costa, do you have a comparative idea of the impact of soiling in agrivoltaics as compared with the standard installation, as there is soil movement and dust production in agriculture? Yes.
It depends which kind of tractor, which kind of machine do you have below the models and how high you put the tracker system. Of course, if you have a small tractor, you will have less soiling than if you have a threshing machine with a 10 meters blade system with move the ground, so you will fill the air with ashes and dust. So of course it's difficult to answer to this question.
Yeah, I do agree. Thank you. Even another question from Riccardo. Since there are plants in north of Italy, how do you manage hail problem in terms of weather revision agrivoltaics plant security? So I suppose this is for Ivan too. It's not very clear to me, the question, sorry.
Well, hail, it's a problem, and maybe in the future will be always worse. And currently there's no a kind of insurance that allow you to be totally far from this problem. What we use two kind of system. First, it's obviously the weather bulletin, so it means that we can simply check what's the weather, and connect our plant with the closer weather station. It means that if we know that a hailstorm is going near our plant, we can turn the panels to reduce the impact of hail, or in the opposite, if the crops are very important, we can do the opposite, so cover the crops and try to protect them. We don't have a specific monitoring system currently for this kind of issue.
If I can add something, which is also a big question in France, this question of hailstorm. The problem we have if it's some case we try to differentiate, well, the insurance basically in the French system, which are normal, are based when they cover you on the diameter of the hail itself. So the problem is we have now some company have some solution about the forecast of hail, but we cannot at the moment forecast the size of we call it the grêlon, the hail part, which is a big problem at the moment, because this would answer us if the crop is covered or if the installation itself is covered. So there's constantly a choice to be made, and it really depends about what's the most valued part in the installation. And here comes the cost of the production itself. So it depends on the crops, the decision you make.
Thank you, Nolan. Next question from Altis Dalto. Here in Italy, we don't have any good indication how to monitor the fertility of the soil for agrivoltaics projects. Can you suggest what might be the most representative parameters to be monitored? Thank you.
On that aspect, I think agrivoltaic, on that case, won't influence in many cases. It won't influence the fertility strategy, and I think it's the same in every country, which meaning like we have and a lot of companies have tools to monitor fertilization. You can have electroconductivity sensoring. You can have some advanced sensor about nitrite, and some system which like measure the concentration of negative ion in the soil solution. But this is the same strategy with or without the panels. There's not, as far as I'm aware of, some already publications saying management should be different. But of course, even if you have no panels, if you want to monitor also the fertility of the soil, you should have some data. Either you install sensor, either you do frequent analysis. And I'm not aware about some specific test trying to figure out if the agrivoltaic has a big effect on that point. As a comparison to hydric stress, burning and heat stress, and on that aspect, I really there's a lot of investigation going on, but on the fertility, I'm not aware about a big investigation on that aspect.
Nolan. Last question from Fonana Soares. What about energy flexibility in agriculture in order to maximize the use of energy locally produced?
Well, if I can say something.
Ivan, yeah.
First of all, agrivoltaic, it's a big challenge for agronomist, engineer, and a lot of other kind of people and professionals that work on this topic. And we can do a lot of things. Of course, we can also, for example, try to understand in which moment it's better to follow the energy consume. And for example, we can put a meter, a system that allow you to understand if there are any consumption in your house or in your building, and in that moment manage with the tracking system in order to maximize the energy production. We can do a lot of things. We are in a very specific and very interested moment, because there's no perfect solution that fit with every condition. We should try to find the best solution for every plant, for every situation. Maybe if in the next year we will have another conversation, I will say, okay, now we have the best solution for Bari or for Milan with vineyard or lemon tree, but probably they will not fit in the same way if we use them in, I don't know, Tuscany or in another region, or if the spot is near the seaside or is on the mountain. We as engineer know at least the how to a solar plant works, but agri PV it's another deal, and it's very important to to fit every time what's the best solution.
Thank you, Ivan, for your question, for your answer. I don't see any other questions, so after very few remarks, we can maybe conclude this webinar. And what is important, I think, to understand, was important to understand today, of course, that each agrivoltaic project, even not promoted by startups or university demonstrators, but just from one simple enterprise doing installation agrivoltaics, is it can be considered a pilot project, because we, in each different pedology, macroclimatic condition, type of landscape, type of cultivation, we don't know exactly how the agrivoltaic system will be interacting with the local living systems, including crops. So what we have to do is just monitor, and we see how much option, and we saw, thank you, Ivan, thank you, Nolan, to show us what we can do in monitoring. The SYMBIOSYST project is working on monitoring too in the demonstrator, so in the future we will have more knowledge about how to do that. But of course, with regards to the soil quality, which is something that emerged quite a lot in questions too, of course, the monitoring is really can be approached through classic tools in soil quality assessment. That's no different if it is agrivoltaics or not agrivoltaics. A good agronomist can do that, of course. And so thank you so much. If there are no other questions or remarks, we can thank speakers. Thank you for joining us. And please keep on following the SYMBIOSYST research project on the websites and on the LinkedIn page that I posted to you. There we always regularly send updates on the project development, and there you will have the announcement when the registration of this webinar will be available online. Thank you so much. Enjoy your afternoon, enjoy your evening. Bye-bye. Thank you.
Thank you. Bye.
Thank you. Bye-bye.